if you look at that slide up there, it's about where the fat point in the market is, and we've got the Prius centered right exactly there. Uh, the plug-in is outside that, okay, outside that sweet spot where the public wants to spend their money. And as the batteries get bigger, you get further to the right. So the challenge is what's the business case to bring that plug-in back into the sweet spot? You know, how do we offset the costs that are going to be there and make a cogent case for the customer, especially since the Prius does so good? That's the problem, is we're competing against ourselves on this product, and we've got a damn good product right there. Okay, next slide. The other thing is, you know, the X Prize gives you $1 million for the first car to go 100 miles per gallon. Why would you do that? Look over here. From where the Prius is here to 100 miles a gallon. If you drive 15,000 miles a year, you're going to save about 100 gallons. Is that worth $1 million? On the other hand, here, if I've got a 2-ton truck and I can move it from 10 miles a gallon to 20 miles a gallon, or even 30, I'm saving 1,000 gallons of gas a year. So why isn't the X Prize for the first 30 mile per gallon 2-ton truck? Why aren't we working where the problem is, not where the problem isn't? It may make you feel good to have a small car that gets 100 miles a gallon, but society wants you to work in the right, left part of that graph. Next slide. This is what our problem is. Read that top line. Even with the best batteries we can bring to the market right now, an all-electric range of 10 miles is too expensive. Even with the best battery we can bring to the market now, with the best lithium-ion battery. And the reason is at the bottom left of the graph. Right there. We design our car for the second buyer. So we want the used buyer to still expect that this car is going to perform adequately for them. That's the case in every Prius you've ever read. We don't have a battery problem. So for a lithium-ion battery, we've got to put extra battery capacity in to account for the degradation in life over time. Dr. Whitaker from Carnegie Mellon will present a very wonderful presentation today on what's going on. So we've got a bigger battery around, we're carrying that battery around, and you're paying for that battery. So that's the problem we've got, is that we have to put a bigger battery in. So we have to come across and figure out how that works out. Maybe it's battery improvement, maybe it's battery management, or other things, but that's a real problem that we have to deal with. Okay, next slide. So we're in a carbon-constrained world. Automakers are going to respond globally to carbon dioxide regulations. These slides here, this slide here shows you the average cost per percentage increase from various types of IC engines. You might notice that the new Prius 1.8 liter engine, as reported by SAE, has set new records for efficiency just in the IC engine. IC engines are improving radically, and you can expect to see in the next 10 years, you can expect to see powertrains in the mid-40s in efficiencies. That sets a very high hurdle up for electric chemistry applications to compete. Next slide, please. Because of this, if you look at where the electric costs are, they're way out to the right, and they do improve carbon dioxide reductions, but they're really expensive in dollars per ton reduction, really expensive. Next slide, please. This was done by Duke, and it's the study of HEV, hybrid, versus a plug-in hybrid in carbon reduction as compared to a conventional vehicle. And if you see the two curves, both at HEV and a PHEV are similar in removing carbon. And this is based on the EPRI NRDC study using US grid average carbon content. And this is on a PHEV 40. If you look at that top curve, that's what happens when you take a Prius buyer and put them in a PHEV. you don't remove much carbon because the Prius is already clean. Unfortunately, or fortunately, most plug-in buyers will come from the hybrid market. Okay, they'll migrate from the hybrid. They're not going to migrate from a 2.5-ton truck. Next slide, please. So if we're going to reduce carbon, you can see from the middle curve, the red curve went up, you can reduce a lot of carbon with a plug-in hybrid, but at a high cost to society. You can see from the bottom curve that a regular hybrid removes almost as much carbon from the market. And the curve going up the y-axis is the cost of, of hybrids buyers migrating to plug-ins in carbon reduction. Next slide, please. This is a plug-in roll, and I think you guys have all seen this. The idea is to nail the short trips where that's predominant number of people are in there, the fat part of that curve. The red curve is the amount of energy that we're replacing, and so plug-ins are good for capturing a lot of trips, not as good for capturing a lot of energy. And I'll show you what that means in a later slide. But as JC told you, our idea is a small battery. Design the battery small and make a business case and charge it more frequently. Okay? That way that when you've run out of battery, the mass-up effect is not as severe in our size as if you had a much bigger battery. And a lot of people figure about 1.5 kilograms of mass-up per kilogram of battery, somewhere in that neighborhood. You know, bigger brakes, bigger suspension, heavier structure. Next slide, please. Okay, Craig told you that there's a problem with hydrogen infrastructure. There is not a problem with hydrogen production. We produce gigatons of hydrogen every year. It's used in the iron industry, it's used in the gas industry, gasoline refinery industry. It's used in the glass industry. It's everywhere. It's ubiquitous. We make it mostly from steam methane reformation. It's about 70% efficient. Today at lunch, you're going to hear some miracle work that Dr. Samuelson's doing. The problem is although we have a commercial hydrogen, an industrial hydrogen economy, we do not have a retail hydrogen economy. And we're not even really working on that hard. I mean, oil companies don't have a hydrogen strategy. The government regulators don't have a hydrogen strategy, but we do have hydrogen fuel cell cars. And just one little idea. You've got to compress the hydrogen to 10,000 psi. Okay, that's a pretty big ask. There are plenty of industrial strength 10,000 psi compressors. That's not a big deal. There are almost no commercial grade or retail grade 10,000 psi compressors, and almost no work. So it's the Achilles heel. You've got this compressor that runs in a terrible duty cycle, and you've got the seals and stuff like that. And it's really just mechanical engineering. It's not the end of the world. It's a little materials and some mechanical engineering, but we're not doing any work to do that. So you have these wonderful stations that we're building with the Achilles heel of a Yestertech type of compressor.